Okay guys, time for a little bit of help. In this particular example, we have an airplane that accelerates down a runway at 3.2 meters per second for 32.8 seconds until it finally lifts off the ground. Determine the distance, or we should say the displacement, that it travels before it takes off. Okay, so in this particular question, what we need to actually determine, okay, is the displacement. Here is asking for the displacement. So displacement, we don't know the displacement. And displacement is going to be in meters of some sort. Let's first write down what we do have. So here we know that the acceleration is 3.20 meters per second. We also know that the time that it takes to do this, to take off, is 32.8 seconds. And there's also one more bit of intuitive data that we know, that its initial velocity, u, being the initial velocity, is 0 meters per second. But you'll see when we calculate it, this is actually irrelevant. So it doesn't actually matter what the initial velocity is. But because we're going to be using our equation, our kinematics equation, it can become relevant. Okay, so here in this particular instance, you need to choose which kinematic equation you're going to use. In this particular equation, because we want to find displacement, we will use displacement equals ut plus half at squared. So if we plug in our values, because we've got some of our values, you'll see that if our u is 0 and our time is 32.8, we know that that particular term is going to be 0, and you add that to half our acceleration, 3.0 meters per second times 32.8 squared. Okay, let's get out my trusty calculator and have a look at that. So this particular term is going to be 0, so we're going to do half multiplied by 3.2 and then multiply that by 32.8 and square that, which would equal 1,721.344 meters. 1,721.34 meters down the runway. Okay, in this particular instance, remember, if we look for displacement, we will need because it's a vector value, so it's 1,721.34 meters